Hi, it's Mike Stevenson here. In this video, I want to talk a little bit about an Azure preview that was released for API management last month, which I think is really interesting. I think it's interesting for me in a number of areas coming from an integration background. API management something I really enjoy working with. Um, from a FinOps and GreenOps background, I think this kind of also ticks a few boxes of things I'd be interested in as well. So let's take a look at this new feature that's been introduced. So first off, we need to think about, let's do some architecture diagrams first to understand how we build up to this feature and we talk about it. So here I've got an example API implementation that we'll use when we talk about this video. So we've got API management that my developer sends messages to. So with the requests then get proxied through API management and forwarded to Azure functions. Function executes on an app service. It integrates with a SQL database to query data and returns that back. Now that's really a logical architecture, very simplistic view of what might be going on. But I think to understand this feature, we need to dig a bit deeper and look at a sort of more sort of flushed out architecture here. So let's imagine we now have this scenario where we actually have multiple deployments of our components here. So developer still comes into API management, but actually we've now got two instances of the function. So maybe they're in different regions. We've got SQL where we've got our kind of primary server and we've got some kind of replication going on for a read replica. So with API management, we could maybe be routing traffic for read operations to read from the secondary location. That's maybe more representative of some kind of real world architecture here. And I think it's probably worth noting in this video, the fact I'm using functions and SQLs just to keep it easy. I think what we'll talk about later in the video is equally applicable if you had AKS and MySQL and Cosmos and other technologies. We're going to be focusing on the API management in a couple of slides' time. Okay, so let's now think about our what does the physical architecture look like? So the first thing is, let's for example say we've got two regions. So for argument's sake, we've got Norway and Australia, and the traffic actually comes into API management, but API management in physically isn't probably going to be one single node. A lot of customers are going to have that global API management endpoint, but they'll actually be gateway instances. So you're going to have, let's say for argument's sake, I've got my primary gateway instance in Norway, and I've got an additional one in Australia. And what will happen is when the traffic comes in on my global, .api, .net, or whatever the URL is, based on where the caller originates from, it's going to route to the nearest gateway instance. So it'll either go to Norway or Australia, and then in the API policy, we can then implement forwarding to a back end, which would be appropriate. So the likelihood is if my developer came to the Australia instance, I'd probably forward to the Australia function app and read from the SQL in Australia. And that would be probably how we'd have an active kind of scenario, and could kind of give that API developer a good experience here. So let's have a look at the new API management feature and see how this starts affecting the thinking about how we might build this API. Okay, so I think the first thing to maybe think about, probably one of the drivers for this scenario is going to be things like AI services being introduced into a lot of API architectures. So I think if you imagine AI stuff like the cognitive service account, AI Foundry with the different models in, they're going to be some of the resources that are going to be really hungry in terms of carbon consumption in the data center. So for me, this is probably one of the key reasons Microsoft are introducing these kind of features, because what a lot of people are going to be doing is they're going to be proxying with things like the MCP features in API management. So let's imagine I expose MCP out to my various chat interfaces. So we'll see we've got Copilot, VS Code with the GitHub, and all of the other different MCP clients you might have. And API management's exposed an MCP server, but then the back end can be things like the function apps, where you might implement an agent that integrates with the model, for example. And because of this kind of extra carbon utilization happening over here on the back end resources, this is probably really the driver for trying to route for companies who are interested in net zero and ESG scenarios. They want to route to the most useful data center to process that AI request. And for me, I think one of the key things is there's probably scenarios here where the best data center to use from a carbon perspective probably changes over time. So I'm going to assume one of the reasons for this will be things like maybe in Australia, when it's daylight hours, maybe there's a lot of energy based off solar, which means the data center is probably running at lower carbon intensity during office hours, but then in the evening, maybe like Australia, for example, I don't know this for definite, but let's assume Australia transitions from solar to some kind of gas, coal type energy infrastructure after hours once the sun goes down. So maybe at that point, the idea is we want to actually route most of our traffic to Norway because maybe their renewable energy is based off wind and waves and that kind of thing, which makes it more carbon friendly for different times. And obviously during the day in Norway, it's kind of at night in Australia. So that's kind of some of the background thinking I think Microsoft will probably have going on here. Okay, so let's have a look at a few of the things that API management are doing to help us here. So the first thing is this example from the documentation. So in the context properties, they've got this new property available in the sustainability info called carbon intensity. So what they were saying with this example was you could build an API and you could set a response header. So they're saying this carbon emission header, and you could basically just populate that and return it back to the caller, and it would give you an indicator of what the carbon emission was. So for me, my request comes in, and let's say for argument's sake, on that global endpoint, I'm in the UK, so I'm nearest to Norway. So my response would take the Norway's carbon intensity, let's say that's medium right now, and that would go back. And then if one of my friends in Australia made the call, they might hit an API management gateway node in Australia, and based on that time of day, they might get a response back that says Australia might be high intensity at that point in time. And that property is really what drives a lot of the features that you're going to be able to do, and also the patterns you're going to be able to do with API management. Okay, so let's look at a use case example now that Microsoft have described here. So one of the ones that they're talking about is about traffic routing, which was kind of what we talked about in the diagram. So over here, we've got the definition for a back end with API management, and here what I've got is this. Again, these examples are from the documentation, but this is the URL for the back end service. And the key bit that you're defining in the back end is the region. So that here you've said, right, this service for this back end runs in West Europe. And then if you were adding other back ends, you would specify which region that they were in. And that's going to be how you're going to be able to map a back end to a carbon intensity to drive this routing. Now over here, there's the definition for load balanced backends. So when you've got multiple backends that you want to kind of treat as a pool, and you want to route the traffic over. So what they've supported here is this preferred carbon emissions. So here I've got a number of different backends, so you can see what they probably had here further down was like a primary and a secondary. So I'll use the regular backend to begin with, and then I'll fail over to the failover backend if there's a problem, or if the kind of the load sort of indicates I need to. But what we've really said with this one is we can use the sustainable backend alongside the regular. So for me, under normal conditions, these would round robin because they've got the same priority and weight. But what we're really saying here is we're adding a condition where we'll only use that back end if the current emissions for that particular region's going to be medium. So here, that's obviously going to link over here. So let's say it was West Europe. If West Europe's medium, then we'll send requests over there. Now, I think when I think about the architecture diagram here, there's a couple of things we've got to think about. So let's say my traffic's coming in and it hits this global endpoint. And if my developer is in Australia, he's going to hit an API management gateway node in the Australia location. So for me, the interesting question here is with the policy, if I've got that load balanced kind of set up, let's say, for example, I'm saying use Australia, but currently Australia is at high and I need it to be medium or low. So that sort of suggests the traffic's now going to route down to the function in Norway instead, and then the rest of the execution would happen down here. Now, what's interesting from a carbon perspective, that probably ticks a nice box that my OpenAI model in the Norway data center is now more carbon friendly because of a number of criteria. So I'm going to get nice ticks in the box for carbon usage. But I guess I'm trading off here because obviously if this node in Australia is now calling the function in Norway, there's going to be a trade-off there where I'm going to pay a performance overhead for that. So these are the kind of things I think as this project goes through preview, it'll be really interesting to see how these patterns flush out, because that maybe I kind of deliberately used an extreme scenario here with Australia and Norway, because the reality is you're probably using regions more closely together, or if you're a really big customer, you might have multiple regions where you've got them running in parallel and you'd have more to choose from. But let's pick this kind of small but really extreme scenario where there'd definitely be a performance overhead, because this developer, as he's in Australia, is the way the inbound routing is going to work, he's going to hit that Australia APIM node. So he is going to hit a little bit of overhead in the Australia data center, even though it's high. But then he's going to forward his back end on to Norway. So it'll be interesting to see how that flushes out. Now, the next use case here is policy control. And I think for me, the routing one sounds great at a high level, but I think there's a lot more kind of detail I'd be interested to understand to see how I would implement that in the real world. Because I think things like, that previous diagram, understanding performance troubleshooting is going to be quite interesting. But policy control is much more straightforward for me. So here what we've done is in the inbound policy, we've got this kind of condition here where we've said the carbon intensity, and I've kind of missed off the end of the screenshot, so I think it's like high and then medium here. So what Microsoft have said in this sample was if the carbon intensity is currently high when this request comes in, we're going to cache some data for a longer period of time than we will if it's medium. So that's going to be a really good policy to implement from a carbon utilization perspective, because in a cache scenario, we're just going to return data straight from API management. We're not going to call those back-end services. That'll take a lot of carbon usage off those services because they won't be processing requests. And the example of the AI model, we'll not be executing the model. We might just be returning a cached response, for example. So here, really, this example of a policy which determines cache duration is a really good example of how you can do this. But actually, the key thing with policy control, it's more about the ability to do a condition based off the carbon intensity to take an alternative action. So you can really build that workflow of how you want your API to execute, depending on whether the carbon utilization of the current data center you're in is high, medium, or low. Now, I think it'd be quite interesting here. The policy you're going to get in this current carbon intensity, you're going to get the data center carbon intensity for where the node for API management's running. So I'm not sure yet whether you'll be able to query other regions, and I guess that's where the policy control combining the routing maybe comes into play a bit. But this is a good example. It'll be interesting to see the kind of things people do with policy control factoring in carbon intensity. Okay, so that was my kind of brain dump of how Microsoft have put together some of the documentation for this preview. I think there's some really key questions for me that I hope as it transitions from preview to GA, I hope there'll be a bit more information comes out. So I think the first one up at the top here, I think is a really important one. So a lot of the decision making we're going to be making in this, either the policy control or the routing pattern, is going to be based on the carbon intensity for a data center. And I really want to know how often is that refreshed, because if I think about some of the sustainability data that I read in the things like the sustainability APIs about how my resources are used, and that data is often like weeks out of date. So it'll be interesting to know how often Microsoft are going to update this. So for me, we really need that carbon intensity to be updated at least hourly for it to really drive an effective policy. Otherwise, if it's stale, then the anything you're doing is really kind of going to affect your users, but it's not based on real time carbon intensity. Now, my assumption here is they're going to have some kind of model that'll update that value, and it's got to be based on things like the time of day, the region you're in, and like the kind of the pattern of what it typically looks like every day. Is what I think it'll be driven on, but there's not really anything that explains how, either one, exactly what they mean by carbon intensity, and two, how often that value gets refreshed. I think that's a really important thing to come out during the preview. The next one I wonder is this just for big customers? So I think things like the cache examples probably not so much, but certainly the routing example where we're going to have multiple deployments in different regions, and we're going to kind of route based on based on the carbon usage. For me, that feels like something where you're going to need a big sized API implementation to have the different regions to really load balance over. So I think in the past there's quite a lot of times I've seen customers implement an API management where it's very much like an active passive or active active across a couple of regions, and you may use availability zones and stuff like that. But having maybe 5 or 6 regions, I haven't really seen that as often. So it'll be interesting to know if if that routing pattern really is zoning in on just big customers, which I assume it probably is. I think the next one is the trade-off between performance and carbon usage. So a good example is if I come into a data center and then route to another, I hit API management gateway node and then I route to a different data center because the carbon usage is less intense, there's going to be a performance penalty for that because my latency is going to go down. So that's where I think if we think about API management being an MCP server, is probably the biggest driver for that, because I think with an MCP server, the user has an expectation they're not going to get an immediate response. So you're not looking for that low latency scenario that you would be if a user's clicking a button in a website and expects a response quickly. So I think that's probably what's going to happen in that area. But it'd be interesting to know what these trade-offs are going to be once it goes into real world usage. And then the kind of follow-on for that for me is about the side effect. So if I have my request comes in my example, to Australia, and then I route that through to Norway instead, then that routing traffic obviously has some kind of carbon impact. So the question would be, do I actually cancel out some of the benefits of using a less intense data center by having the additional routing overhead? It's probably very minimal and maybe questionable about how measurable that is, but there must be some consequence. And it'll be interesting in the real world to understand what that actually is. And then the final thing I think for me that's really important is, how do we measure if this is making a difference? So I guess if I imagine I've got my application in a subscription, and I'll be to measure, with things like the sustainability dashboards and APIs and stuff, I'll be to measure what my subscription carbon usage is month one. I then implement some of these patterns and I can measure it in month two and see if it made a difference. And I think that's probably going to be how people start measuring this. But you're obviously going to need similar traffic patterns and that kind of thing. And I guess you're going to have to maybe play around with the policies to see if you don't route the traffic or if you don't do the caching, how does that implement, or how does that affect your carbon consumption? But for me, one of the things that's going to be challenging is that where this gets used, I see this being as part of a complex architecture where it's going to be very difficult to understand when a knob's being turned, and it makes take the routing traffic, makes the traffic route another way. How easy is it to measure if that actually lowers my overall carbon consumption or not? At a top level, we can probably measure it, but it's going to be difficult to troubleshoot. A good example would be if my traffic and usage just went up. So it looks like my carbon's going up all the time because I'm getting more users because my app's successful. That's going to cancel out the ability to measure if it's really making a difference when I'm implementing this. So I think that's going to be a really interesting thing. That does the preview cover that kind of scenario, or will that be something people think about later on? I hope this video is interesting. Just a bit of a brain dump about this preview that I thought was really interesting, and hopefully we can get involved in it. Thank you for listening to today's video.